Kia ora, here I am back with the TGC derived grade exam for Level 2 Chemistry 2024, and this is the organic paper question 2. Right, we start off in this question with a primary, secondary and tertiary classification. So when you're asked for that, you're going to find the carbon with the functional group, and you're going to see how many carbons that is bonded to. So that's secondary. Here's the carbon with the functional group, and that is only bonded to one other carbon, so that's primary. Here's the carbon with the functional group, and that is bonded to 3 other carbons, so that is tertiary. Okay, and it asks us to explain our classification of compound L. So we've said compound L is tertiary, and we just need to put the thinking that we went through into words. The carbon atom with the functional group, and let's say what that is if we know, and we do. The functional group, Cl, is bonded to 3 other C atoms. Therefore, L is tertiary. That's it. Nice and easy. Okay, let's turn the page. All right, this is the one that people hate the most, but again, we're just going to apply our rules, right? The carbon skeleton does not change. The functional group does not change in one reaction. The position will stay the same, and you must be able to name your products. So if we've got D here, and look at the carbon skeleton, it's a prop with a methyl off it. Right, so everything is going to look like this, right, a version of that. So my first one is this one here. I've got a double bond, and I'm going to add hydrogen with a platinum catalyst. So I'm going to take the same carbon skeleton, back to the same carbon skeleton in all of them, and all I'm going to do is I'm going to break the double bond, which is this one here. And I'm going to add hydrogens across the double bond, so I'm going to end up with that. Okay, so an H there and an H there, which I've got here. Now, I haven't drawn my hydrogens in. If this is an exam, I have to draw my hydrogens in. Otherwise, I'll get it wrong. All right, coming over here now. So compound D to compound F. We've still got the same carbon skeleton. I've got an H2O with an H plus catalyst, and as soon as I see a double bond, it's most likely to be an addition. So I'm going to copy this again, and this is for F. So here I have these carbons. Oops, sorry, I'll pull that down a bit. And break the double bond and copy all the other hydrogens in. So that one already had 3. That one already had 3. That one didn't have any, and that one had 2. Right, so this time I'm going to add in my H2O atom, so an H and an OH, and I want the minor product. So since this is addition, we're adding, so it's rich get richer. So let me look at these previously double bonded carbons. This one had 0 H's, and this one had 2 H's. So this is the rich one. So I'm going to put another H on that one, and I'm going to put my OH there. Oh no, that's my major. Geez, must life. Crikey, get me rubber out. Okay, so I'm going to put the H on the other way round and put my OH there, and that is my minor. My major, which is going to be compound G, is where the rule applies. Okay, that's what some people sometimes get a little bit caught up over. When we say rich get richer, we're talking about hydrogens, and the rule is the way we find the major. Little clue too, and that's what alerted me, the major product usually has the functional group somewhere in the middle of the chain and the minor product at the end. It's not a rule we talk about, it's just what happens. Okay, so we've got F and G, and now we've got H, which comes from G. So that's the same carbon skeleton again. Everything is the same carbon skeleton. So you should be able to draw your carbons in no matter what. And G has come from this thing here. So we've got the same carbon skeleton. All they've done is flip it over. So I might just flip it over so that it looks a little bit like this. See, I've got the CH3 up the top and they've put it down the bottom. So I'm just going to draw that in the same way that they've drawn it. It just makes the pattern easier to see. And the reaction I'm now looking for is the chloro plus ammonia, alcoholic ammonia. So that's a sure sign. I'm going to substitute that in for the functional group. So that's going to give me an NH2. And then I'll put all my hydrogens on. Okay, so that's my E, F, G, and H. The next thing I have to do is my reagents. This is the bit that a lot of people find trickier. Okay, R1 is going from compound F, which is alcohol, back to an alkene. Another way to look at this is that we've done an addition here. The opposite to an addition is an elimination. Okay, they're opposites to each other, so that can be another useful pattern. So there's only two eliminations, and this one's coming from an alcohol. So the reagent that we want, R1, is concentrated H2SO4. That's our dehydrator. So we're removing water. R2 up here is going from our alcohol, which is compound F, to a carboxylic acid. So compound F here's got an alcohol on C1. Now there's a carboxylic acid. So that's an oxidation. So I need to add Cr2O7 2- /H+, and let's just put in heat, or MnO4 H+ heat. And if you're not very good at remembering the formulas right now, if you haven't done redox yet, which we haven't, then my suggestion is that you can just write dichromate or permanganate. That's fine too. They haven't said the structures of the reagents. So if I were just to write dichromate H+ heat, that would be okay too, because you don't want to get the formula wrong. Okay, and the last one's R3, which is going from G, which is our alcohol. And it's going from an alcohol to a haloalkane. So that's a substitution. I'm swapping my OH for a Cl. It's a tricky one. You've got to find something with a Cl in, but this is one of our pickles, right? So this is pickle 3 or pickle 5 or sockle 2. Any one of those. Okay, and our last part for question 2, I think, yes. In the scheme, given in part B, there are 2 possible products for the reaction of D with H2OH+. That's this one here where we got major and minor. These are labelled as compound F, which is minor, and compound G, which is major. Explain the chemical process that occurs in this reaction. So we need to state the type of reaction and justify it. How do we decide which are the major and minor? And what are the structural features that allow 2 products to form? Right, so we've got our reactions written, but I mean, if we wanted to, we could write them again. So I could write down this again, just so that I have got, just so that I've got it in front of me, and I'm going plus H2O/H+, and that is going to one of them, right, and the other, which looks the same. See if I can fit it in here. Yes, I can. But with the OH on the other previously double bonded carbon. Okay, so this is an addition reaction. Oops, an addition reaction. The C to C double bond is broken, and 2 new atoms or atom groups are added, 1 to each previously double bonded carbon. Okay, so that's my type of reaction and my justification of my choice. Probably best to link it in this case. the added atoms are H and OH. Okay, next step. How did I decide major and minor? Okay, I'm actually going to come down to discuss the structural features. I'm going to say as the alkene is asymmetrical to different C atoms in the double bond, and H2O is asymmetrical, and by that we mean different atoms are added, right? So we're adding an H and an OH, they're not the same as each other. Two products form, and that depends on which double bonded carbon gets the H and which gets the OH. You could write that down, but I'm not sure that we need to in this case. And we get major and minor. The major product forms when the previously double bonded carbon with more H's, the rich, gains another H, gets richer, and in this case, this is methyl propan 2-ol, which is G. The other is the minor. In this case, this is methyl propan 1-ol, and that's F. And I think that's it. So I could come up here and go, that's the minor, and that's the major. And I could come over here and I could go, here's my two previously double bonded carbons. This one's got 0 H's, and this one's got 2 H's. You know, so I could put little things like that to help me. Essentially, that's question 2 done.